Well, good morning, everyone. Thank you so much for joining us today. George is going to put on a great presentation for getting the most from the key influencers visual in Power BI. Sorry. Just wanted to thank you guys again for coming. Go over a few housekeeping things. We're going to have Q&A at the bottom of this Zoom session. So if you see something that's interesting, please feel free to type a question or raise your hand. Greg Bounds, one of our senior data analysts, or Christian Denison, one of our other data analysts at IronEdge Group, will be either jumping in and answering it via text, or George can answer it live at the end of our webinar. Would love to go ahead and introduce George Sturrock. He is the Director of Business Intelligence for the IronEdge Group. George has been with our team going on 1.5 years now, and he has a master's in data science. He specializes in the Power Platform. Pretty much any question you have around it, he can go ahead and answer. At IronEdge Group, we focus on Power Platform consulting and helping out our clients with training initiatives, proof of concepts, data strategies, and BI as a service. So we hope you enjoy our webinar today.
Excellent, Cassandra. Thanks for the introduction. I'm never comfortable talking about myself, so I'm glad when people do it for me sometimes. All right, so let's get started. So what we're all here to learn about today is more about the key influencers visual from Microsoft. This visual is roughly a year or so old, at least a year or so out of beta. So it's released into the wild. When you download the most recent version of the Power BI desktop, you will see the key influencers visual in there. Given my interest in BI and data science, I was actually a little hesitant to adopt the key influencers visual when it initially came out. After really playing with it a little more and using some of the knowledge I have to really extract more value from the key influencers, it's really become a key visual for us and it really helps us approach and build really compelling dashboards for our customers. And as such, I wanted to share some of those tips and tricks, those really are actually kind of no-code, very simple tips and tricks that we use with you guys. So who is IronEdge? And I know you guys didn't log in to hear a sales pitch, but we do want to introduce ourselves and talk about who we are a little bit. So we are a technology and consulting company based in Houston, Texas. We're not a Johnny-come-lately. We've been around for 14, 15 years. And we have a very, in my own opinion, a very strong BI team. And we have what we also consider kind of a unique way to deliver BI solutions to our customers and partners. For more information on IronEdge, you can reach out to Cassandra or Haley after the webinar, or myself after the webinar is done. And now specifically onto my team, when we start talking about the Power Platform and Power BI, we work across we do a wide range of services within the Power Platform and the Azure Data Platform, focusing on Power BI, Power Apps, and Flow, right? So we do Power BI projects, we do training, usually, and typically our training is group-based, in person. We come on site and deliver training to you guys. We also do BI as a service, which is more of a subscription type of service. But again, if you're interested in any of these offerings, please give us a call and follow up with us after this webinar is done. A little bit about me. So I won't go into depth about who I am. Cassandra did a good job really kind of kicking off some of my past experience and more current education. But one of the things I'm really fascinated by is really where BI meets machine learning and AI. I've found a lot of data scientists sort of view BI as something that's, I probably shouldn't say this, but a little bit beneath them, right? And I think the people that have that opinion really kind of are missing out on the boat, right? And missing out a little bit, right? When you start to integrate end-to-end data solutions, BI should be part of your strategy as well as data science, right? The two really work off of each other. And again, at the bottom, if you'd like to stay in touch with me, there's my IronEdge email. If you have any questions on this afterwards, feel free to email me. If you'd like to stay in touch with our business intelligence blog, that's the second link there. If you'd like to check out any of my projects that are done without sensitive data, open data sets, you can check out my GitHub account as well. So what do we actually want to get accomplished today? So obviously we want to provide you guys with an overview of the Key Influencers visual. What is it? How does it work? How do I interact with it? Right? We want to talk a little bit about the statistical models that power the Key Influencers visual. We're not going to go super deep into statistics, right? We're only here for 45 minutes to an hour, so we don't want to turn this into a statistics class. And we'll talk about some of those simple methods that we can use to, and they're all low code methods or no code methods to get better results from the Key Influencers visual. Then the fun part, right? We'll jump into a data demonstration in Power BI, and then we'll discuss a little bit. We'll wrap it up and discuss a little bit about how we apply the Key Influencers visual on our projects and how that may translate into your day-to-day work as well. So what is the Key Influencers visual, right? So we talked about this a little bit. The Key Influencers visual, it uses statistical techniques like linear regression, logistic regression, and decision trees to really give you insights into your data set. One of the more important things to really realize about the Key Influencers visual is that it's not a prediction tool, right? We're not going out and doing training models, testing models, and then deploying models to be used for prediction. Microsoft really positions this as a tool that is a gateway to start exploring influential attributes and features and columns within your data set. Microsoft has excellent documentation about the Key Influencers visual, and the link to that is shown at the bottom. So why is this important to me, right? Why do I even want to listen? Why am I here today? Why do I want to see George talk about the Key Influencers visual, right? So one, it's fantastic. And again, I'll be honest, when it first came out, I wasn't a believer in it, right? I've only become a believer in it, just after using it and seeing how easy it is to interact with it, and actually how accurate it is from a statistical standpoint. It's simple to use. You don't have to write a lick of code. It does everything for you. However, what we can, right? So a lot of times what we see with the Key Influencers is people really just load up the column load up the visual with basically every attribute in their data set, right? And then extract whatever, and then say, okay, whatever rises to the top, that's what I need to focus on. So that's one way to do it, right? You can do it that way, but we can do better, right? And we're going to give you some of those tips and tricks again today. And again, it's worth noting the Key Influencers visual, it is an informational tool. It is not a predictor, right? It is something that is a starting point to drive meaningful analysis and build meaningful dashboard experiences for your end users. So I said this wouldn't be a statistics lesson, and I'm going to stick to that. I just want to go just a little bit under the covers here about the statistical models that are found in the Key Influencers visual, and that really drive what's going on. So you really have three areas that you're talking about. Microsoft leverages linear regression and simple linear regression. We're not talking about, for those of you who know a little bit about regression techniques, we're not talking about elastic net or lasso or ridge or anything like that. Really simple linear regression. Also logistic regression, right? So that's a means of classification. So either binary classification, classifying something as yes, no, or multi-classification. And we'll look at an example of multi-classification with the Key Influencers visual today. And then we'll dig in, we'll start to dig in even deeper to the Key Influencers visual and look at how Microsoft really represents decision tree data. And decision trees, if you're not familiar with them, they're exactly what they sound like, right? So if you see, in the visual up here in the upper right, this is actually a simple decision tree based off of the Titanic data set, right? So the passengers on the Titanic who survived, right? So this is what a decision tree really does, right? It starts to break down your data population by different classifications and different attributes to try to reach, to try to help us, help guide us through the data and find really what drives actions or classifications, or in this case, survival rates. And I know that was a very lightweight introduction to linear regression, logistic regression, and decision trees. So if you have more questions on that after the webinar, we will, please feel free to get in touch with me, but I'm going to stick to my promise and not make this a statistics lecture today. So here's really what we want to do, right? So we talked about the example where people really just throw they throw the kitchen sink into the key influencers visual, and then they start looking for those influencers that rise to the top. Like we said, we can do better than that, right? What we're going to talk about today at the bottom is really some of those no-code column steps, right? And so 4 column selection steps. And for those of you guys who are data engineers, data scientists, or statisticians, or have just a really solid background in any kind of quantitative data analysis, yes, I know there are ways I can make this even better that involve going in and altering the data. And I used to talk about those a lot with the key influencers visual, but I really kind of stepped back from that point. My recommendation for those of you who maybe are not data engineers, data scientists, or quantitative analysts or statisticians is really stay away from fundamentally altering your data, right? Once you start altering your data, and you have to remember this is a BI model, right? So a BI model has different needs than a data science model or a predictive model. You're really, if you start doing techniques like filling missing values with median values or mode values or mean values, things like that, you're fundamentally changing the data that goes out the door to your consumers. So if you do that, things like that, you could get even better results from the key influencers visual. But think about what impact would that have on your end users, right? Would they start making bad decisions based on data that we've created, that we've introduced into the BI model to help get a better result out of the key influencers visual? And again, I'm not saying don't do it. I'm just saying proceed with caution when you start, if you're going to start altering the data inside the BI model. So not to beat a dead horse here, but in this presentation, we're going to stick with the no-code column selection steps, things that we can do that don't involve changing the data. So first, we'll talk about features, and in this case, features. I'll use the terms features, attributes, and columns almost interchangeably during this presentation. But if there's features with really no value to a statistical model, things like if column is all 0, right? So if we look to the right here, and we see in this case, just these 4 or 5 observations. If we pretend that's the entire data set. Wind speed is all null values. If I have a column that's all null, obviously that's not going to do me a lot of good, right? In any kind of regression scenario or something like that. Similarly, if I have a column with very low variance, so if I saw, again, if we pretend this is a 10-column data set, if I saw null of wind speed in every single column, in every single cell except for one, does that really help me, right? Those are things you have to think about when you're going through this. On the other side of the coin, there's things with extremely high variance that probably have 0 statistical value. So things like for those of you guys who are into database development or data management, row IDs, surrogate keys, GUIDs, those globally unique identifiers like we see over here in this one screen print from the Pocket GUID test. Things like that are meant to make data totally unique, right? That doesn't help us with a key influencers visual, right? So the good thing is We don't have to write any code, right? We don't have to go back and manually drop these from our data set. You just don't include it in the key influencers visual. It's great. Second, we'll talk about leakage, and this is kind of, another statistical term, right? So when we talk about leakage, we mean we're using data from past events, right, to really tell us data outside the data set, typically, to tell us what's going to happen with the data set that we're trying to do, right? That's probably not the best explanation, but if we break this down to an example, this was some, and for those of you guys who participated in Kaggle competitions, you've probably heard about this. There was an example where we were trying to predict, we were using every single shot in Kobe Bryant's career, right? And then going back and trying to, see if we could create a model that could predict whether or not Kobe Bryant would make a shot, right? And so, this was a classification problem, make or miss. What people were doing in the real world is that they were, not in the real world, but in the Kaggle world, is that they were going out and instead of trying to build a statistical model, a machine learning algorithm to do the classification, they were going out and scraping ESPN's website, right? And so they knew, they were introducing that into their model. So they already knew if Kobe Bryant had made or missed a shot, just because they went and got the data from outside and then injected that into the model, right? So that obviously that raises ethical concerns, but that's what we call leakage, right? If you're using something that is a self-fulfilling prophecy, that really doesn't help us. And we're going to look at some examples of that as one specific example of that as well today as well. And so missing data, right? So this is something that we deal with in the BI world, the data engineering world all the time, right? So in Power BI specifically, sometimes you'll even see, maybe not missing data, but you'll see error values pop up in Power BI, right? So that's when your Power Query bombs out, or if it doesn't bomb out, it kind of sections those errors off into a different table so that you can go back and do it, go back and fix those. Luckily for us, key influencers, it handles columns with missing values very gracefully, right? As opposed to if I was writing code in Python or something like that. But just because it will work with missing values doesn't mean we shouldn't examine that on a column basis, right? So we have our little screen print here that we saw before with wind speed and wind direction, right? So if in this one it's missing a lot of wind direction, right? In our sample 10 row data set, there's not a single column cell that's filled out, right? So if we let this, so we already talked about this a little bit with features with no or low statistical value. Similarly, if you're missing a majority of your values, what good will that do for your prediction or the values that the key influencers visual spits out, right? And again, this is something where you may need to bring in the expertise of someone with good domain knowledge, someone who really knows the data from a business perspective, to really give you a guidance on that, right? So if we pretend that wind direction is only populated in 25% of the rows, should we include that? Maybe, maybe not. I would, as a data guy, I would say no, don't put that in your model. But if you go to a data expert, your business data expert, they may say, you know what, that 25%, that's still valuable to me. Please include that. So there's two ways there's two no-code ways we could deal with missing values in Power BI. Number one, we can just delete all the rows. If there's a missing value on a row, just delete the whole thing. That is a last case resort, right? That is not what that would not be my first go-to for dealing with missing values, right? Every row of data that you have is precious, right? So if we start tossing those out of the model, maybe we may not be doing the best for both our modeling and our ultimate BI solution. Single imputation, right? This is another one, right? And this kind of goes back to where I talked about being careful with actually filling values within your BI model. But things like filling a numeric column with nulls or missing values like we have with wind speed. Again, it helps if you have either a domain expertise on the data set or someone who can help guide you. But there are very simple things you can do within Power Query, like with zero filling, forward filling, backward filling, or you could do the thing that I said be careful with, fill it with statistical values like mean, median, or mode. So again, we're going to get to the fun stuff pretty quickly here, but I just want to go through the background and really kind of some of the theory that we want to talk about here before we jump into the live demo. And this is really probably one of my favorite things to talk about is attributes with no practical value, right? So this is where we get our person with domain knowledge. And you hear me say that a lot. Domain knowledge, really in BI or data science, it's critical, right? Someone who really knows the data from a business perspective is absolutely invaluable, right? So we may go through the key influencers visual and we may pop up something that is highly, according to key influencers, highly influential. You take that to your boss, your data expertise, your data expert, or your subject matter expert, and they may say, yeah, that has absolutely no. We realize that statistically it's significant, but for me that has absolutely no value to me, right? It's a non-factor in this data set. That's critical. That's important feedback. On the other hand, right? On the other hand, something you don't want to go to your boss and say, your boss or your decision maker or the ultimate consumer of your data and say, look, I found something that's really highly significant using the key influencers visual if it's something that basically says water is wet, right? So to kind of illustrate that, I'll just relay an example from my past. A good friend, a very good friend of mine who is a smart guy, and is a data scientist. His very first data science project, he was working on a sales project. And this isn't someone at IronEdge, right? This is someone outside of the IronEdge world. And he was working on a sales project. He was trying to predict whether or not a customer would buy or not buy, so a classification problem. He did all of this, he did it by the book, went through, covered all his bases, right? And then took his, had high accuracy on his model, took his findings to really a VP of sales, and basically told him that, hey, I'm really onto something. I found something that might help you. People with more money are more likely to buy stuff than people with less money. So just imagine that. Imagine, and I promise this is a smart guy. Imagine going to the VP of sales and telling him that, right? Number one, that might be a career limiting conversation. Number two, what value did you actually survive, right? Did you produce, right? You basically told him that water is wet in his terms. So just be mindful of that. And again, let's talk about variables, columns, features, attributes with high correlation, right? And what we mean by high correlation, it's really columns that work in tandem with one another, right? So as one goes up, the other one goes up also. As one goes up, the other goes down. So that can be positive correlation, like we see in the picture here, or negative correlation. And why it's important to actually look at the correlation of columns is if you have basically a lot of columns that say the same thing in the key influencers visual, it could falsely inflate the importance of some of those. It could falsely inflate the importance of some of the features that you put in there. So you really want to really minimize the number of highly correlated columns you're throwing into the key influencers visual. Now and we'll go over this also in real time in the demo, but there's a simple way to test for correlation within Power BI, right? You can go and import the correlation plot visual that's free to download in the marketplace. This does require that R is installed on your local machine to make this work, right? So if you have R, I believe it's R version 3.4 or higher. I can't remember exactly, but you'll have to have that installed to make that work. So that's a consideration if you just don't want R installed on your machine, or if you have to go and get permission from your IT group to get R installed, maybe you just go back to the business data expert, right? You start asking them, what variables are related. There's also other ways we can do that, right? We can start doing scatter plots like we saw here with perfect positive correlation. Put variable 1 on the y-axis, variable 2 on the x-axis, and see how they plot out a certain data point. So here we are, right? So we've gotten through some of the theory that we've talked about, some of the things that look for, and some of the things to look for, and now we're going to actually jump into Power BI. And within Power BI, we're going to use Kaggle's NFL Big Data Bowl data set from 2020. And this particular data set contains basically, I don't know, a lot of information about rushing plays that took place between 2017 and 2019. So it's actually a pretty big data set, right? So, and the whole point of this exercise was to try to create a machine learning or statistical model that can accurately predict the yards per carry, right? The yards per carry, given what we know about a rushing play that's about to happen. So pretty interesting stuff. If you're interested in sports analytics like I am, I would advise you to check that out. But instead of building a machine learning model, we're going to use key influencers to see if we can identify some of the more meaningful attributes and columns in that data set. I couldn't help myself. I had to go through and add a few more columns, and those are listed here. I would advise you guys to really pay attention to the bottom two. Run class and opposing territory end up appearing a lot in the key influencers visual. So without further ado, and I do appreciate you guys bearing with me going through the theory. I will now jump into Power BI Desktop. So I've already done this for you. If anyone who knows me knows I don't like totally live demos, right? I like to have things prepared. So I've gone through and prepared, set this up, set the journey up for us in Power BI. So let's look at the key influencers visual. First, I'll show you guys how to drop this in. So you can find the key influencers visual here on the Insert tab. And for those of you who have not turned on the new ribbon, I would highly advise you to turn it on. It's awesome. So you can insert the key influencers visual by clicking here on the Insert tab, or you can see it in your visualization pane. Right? You can drag that into your model, and then it just becomes like any other visual in Power BI. Right? You have the Analyze bucket, so that's what we want to analyze. So in our case, it's either yards per carry, or maybe even run class. The Explain by buckets, those are the different columns that help us analyze either run class or yards per carry. So let's jump back to what we have here. And I like asking questions of the crowd. And again, just for these questions, you don't have to raise your hand and talk. Just fire your answer into the chat box. But if we do a few concept checks here on what we just talked about, so in the model that we see over here on the left, right? So right now we're doing a classification model, right? So it is using the custom column that I created, long run, we call it run class, right? To classify runs by being long, short, or where we lost yards. So first off, and you guys fire this into the chat box. What type of classification problem is this? Is this binary or multi-class? I'll give you guys a second while I take a sip of water. All right, I don't have any takers on that one. So this is a multi-class classification problem, right? We have more than two buckets. We have three, in fact, right? So this is multi-class classification, which is going to use logistic regression. So if we do another concept check here, maybe we'll have some braver souls here this time. But when we look over here, so when we tie yards, and this means yards per rush, right? So this is the actual yardage that a running back gained on a single play. And we tie that to the run classification. And if we remember, run class is a long run is greater than 5 yards. A short run is in between 0 and 5 yards. And lost yards is you're going backwards, right? So it's less than 0. So if I leave yards per carry in here, and again, this is multiple choice, right? And feel free again to fire your answer into the chat box. So the relation between yards being used to explain run class, is that an example of missing values, a feature with no practical value, leakage, a slippery slope, or high correlation? And this one's a little tricky. Again, any brave souls who want to fire their answer into the Zoom webinar chat, please do so. All right, no takers again. All right. Well, I will. I'll tell you on this one. I would have accepted either high correlation or leakage. Right. I personally kind of classify this as leakage because it's something I injected into the model, so it was something from outside. But high correlation could. High correlation could. I would have accepted that also. Oh no, Leslie, I'm so sorry. I just saw the chat box is disabled. So there were probably several brave souls that were typing in answers, and so I apologize for that. Maybe one of the panelists or administrators can see if they can enable the chat box.
Hey, I'm sorry to interrupt, George. Could we go ahead and use the Q&A for that then, just to make it easy?
Sure. Yeah, fire it into Q&A or to the chat box. It looks like the chat box might be open. And Leslie, thank you for letting me know. Okay, so here's part 2. So we'll test to see what happens here. So how might you? Here's another one. So we see if we flip over to short run, right? This classification, we see jersey number pop up. So how might you guys classify jersey number for this? Is it a missing value, no practical value, leakage, slippery slope, high correlation? Again, Q&A or the chat box is fine with me. Maybe a few more seconds. All right, no takers. So I call that one no practical value, right? So so yes, you could make an argument. You could probably make an argument. Okay, so maybe that was a wide receiver because maybe that's wide receivers might have running numbers that are below 19 or lower. Running backs are typically higher than that in the NFL at least. But I'm going to submit that jersey number really has no practical value for me, right? So does that mean if I go way back, Emmitt Smith, number 22, if he had won number 21, would his career numbers have been any different? Probably not at all. Okay, so we went through some questions. Let's really start digging apart what's going on here before we follow the analytical path that we have. So I'm going to switch back to the factors that influence long run. So, and this is with every single thing in the database thrown into key influencer. So we're going to get some screwy things, right? But what's going on here is key influencers makes it so easy, right, to interpret what's going on. Really, they've made it to where you just read it. So if any of you guys have ever had to interpret the output of a statistical model, it can be a little difficult, right? You have to have some training. You have to know what you're looking for. Here within the key influencers, you really just read it, right? So if the yard line, if the yard line is greater than 12, isn't that interesting, right? Because there's two 12-yard lines on the field. So if you're in between the 12, it's more, you're 1.78 times more likely to have a long run, right? Isn't that interesting? That's so fascinating to me. And we can go down and we can start to see some of the other factors that influence this model. And again, this is a logistic regression question here. So we can also go into top segments. And within top segments, again, maybe not so interesting with a long run. Let's try a short run and see what happens. Please. One segment. We'll go through this anyway. So what we're doing here is we're really using decision trees, right, within the segments. So what it's really saying is, now get this, right? This is another one of those career limiting conversations that you're going to have if you're talking to a general manager or a scouting professional. So, if you work in the NFL. So if I go up to you and say, hey, I'm on to something here. If you run for negative yards, that means you lost yards, right? So it's a simplistic example, but this is a decision tree. And of course, we would expect 100% to go into that bucket, which it does. So cool. So let's move on here. So let's look at some of the variables or columns or features, attributes, whatever you want to call them, that probably add no or low statistical value, right? So we have ID fields like game ID, play ID, NFL ID, NFL rusher ID. These are all GWIDs, row IDs, things like that. And then we have another, variable, the one that I injected myself and then filtered down to 1 within Power Query, that has 0 variance, right? So these do nothing to help us. So if we move over here to the leakage tab, I've removed those. So we'll see some changes here. It's running its analysis. Look at this. Wow, all we did was remove variables with no statistical value, and look how everything changed, right? So now, I guess if you're Taylor Gabriel, right? So if you're Taylor Gabriel, you're more likely to have a long run. And again, we'll get into this. There's probably no practical value in having the player's name in this step. Going forward, let's look at and we're on the leakage tab, right? So what might be, and I know this is a fine line, right? We could call yards, we could call this leakage, or we could call it just a highly correlated value. But just for purposes of this presentation, I'm going to call it leakage, right? Since it's correlated to something that I introduced into the model from the outside, and distance traveled as well. So we're going to take those out, and now we're going to see really how this thing starts to change, right? So now compared to the prior tab, and again, this is just by moving things that introduce leakage. We start seeing other things pop up that influence a long run, like the numbers of the defenders in the box, right? So people who are close to the line of scrimmage, kind of your offensive personnel groupings, things like that. We still see a whole lot of just names in here. Again, I would submit that those probably don't have a lot of practical value, right? And the reason I would say that is, if you leave a player's name in this model, in my opinion, you really put yourself again in the NFL data analyst who goes up to the GM and basically you're going to come back and tell them that last year Christian McCaffrey was a better runner than Carlos Hyde for the Texans. Let's say Carlos Hyde had a great season, but if you go and tell your boss that Christian McCaffrey is better, he's going to say, yeah, no kidding, thanks, tell me something I don't know. And if we flip this over to short run, we see jersey number rising to the top. And again, I don't think that has a lot of practical value. So if we start taking out values columns that have no practical value, like jersey number, now we're really getting somewhere, right? We're really starting to see things that could influence whether a run is a long run, a short run, or if you're going to lose yards, right? So interesting. So first or second down, right? On first or second down, you are 1.24 times more likely to have a long run than on third or fourth down. Isn't that interesting? This X variable is basically where you are on the field. So this is a vector, kind of a vector that means, if I just interpret this for you, you're between like your own 10-yard line and the opponent's 11-yard line. That's what that means. And we've also seen something new pop up on this visual. So we now have the ability to sort by count or impact. And I love this, right? So this is one of those little bitty tools in the key influencers visual that really speaks to the thing that I like to talk about. So practical value versus statistical value. Let me show you how to enable that. So if I go over to the format pane and click analysis, simple. I can just enable counts, right? So if I toggle that off, it disappears. If I toggle it on, it appears. Very simple. So here I can see that now we start to see other things that affect long runs, like game weather, right? And that might actually make some sense, right? So if you're running on a muddy field in the snow or in the rain, that may influence the length of the run that you're able to make. But here, let's read this a little bit, right? And again, this is relevant to practical value. So when the game weather is clear or cool, the run class is 3.02 times more likely to be a long run compared to other values. But let's read on. This influencer contains approximately 0.07% of the data, right? So is this statistically significant or is it practically significant? It may not have, given the fact that it doesn't occur much, it may not have much practical significance, right? And sure enough, we click count, and where does it go? You'll just have to trust me. It's down here in the bottom, right? That's something you have to think about. Again, let's jump over and let's move along the journey here. And this is another thing I would ask for you guys. Really, does the stadium type have much practical value, right? So we'll see things like, oh, let me switch over to lost yards. Oh, sorry. So this tells us, if I switch over to lost yards, this tells us that if the stadium type is a retractable roof and that retractable roof is open, I'm 3.36 times more likely to have to lose yards on a run. Does that make sense to anyone? It really doesn't make sense to me. I'm gonna call that no practical value. So with no practical value, again, I'm just gonna take it out of my model over here. Boop, stadium type gone. And so now we're finding something out that's a little more interesting and probably a little more logical. So if a defense is rolling out a lineup with 6 people on the defensive line and 2 linebackers, so 8 people in the box, you're not going anywhere. That's what this is telling you. Doesn't that make sense, though, for those of you who are football fans? So let's jump over to high correlation. So by this time, we've taken out everything with no statistical value, low statistical value, leakage, missing values, no practical value, things with no practical value, and we're left with this, right? So here, I've plotted this into, right, the correlation plot that we saw in the PowerPoint. And here, let's look at this a little bit. So things with extremely high positive correlation. So as one thing goes up, so does the other one. They show basically in bigger, darker blue balls, right? So these that you see here, this is obviously there's going to be a perfect correlation between defenders in the box in itself, right? That's why you see these in this horizontal line. But hey, let's look at some more interesting things like speed and distance traveled, right? So the faster you run is there's a strong positive correlation to how far you're going to run, right? Whether that's horizontal or vertical up the field. If we look at something else, we see this orange ball here that's pretty good size, and it's saying that week and temperature are negatively related, right? And doesn't that make sense also? So this is the week of the NFL season. And we have to keep in mind the NFL season starts in September, it ends in the regular season and ends in December, right? And so you would expect as the week number gets higher, the temperature is going to go down. Doesn't that make sense? So here for high correlation, I removed distance traveled. I kept speed just because I think speed that was just a judgment call for me. And I took out the categorical defensive personnel and then just left in the numerical keep defenders in the box, because to me those are logically related to each other. So here now we're really left with something that's interesting, right? So now I will tell you that this matches up fairly nicely to people who actually did the full-blown statistical analysis on those Kaggle competitions, right? So we see things like the player size, how fast they run, the offensive personnel lineup, the defensive strategy, the type of surface, the weather, down and distance. Those are the things that pop up here as the factors that influence whether you're going to really break a long run, lose yards, or just have a average run-of-the-mill rushing play. Whew, that's a lot of talking. So maybe let's see if we have a better decision tree or segment-based population than we had before. So here we're looking at runs at lost yards. Let's look at this first box, right? This first segment. Isn't this interesting, right? And doesn't this make sense? So if you're not really running fast, right, or if you're accelerating slowly, you're more likely to lose yards. If the defense is really stacking up a lot of people on the line of scrimmage, you're probably not going very far. In fact, you're probably more likely to lose yards. That's what this is telling us, right? Doesn't it make sense? Isn't this interesting? Isn't this something I could take and apply in my real life? In real life. Let me go on here. I'll show you guys. So we looked at all of this was logistic regression. I also did a linear regression just based on yards. Linear regression is a little different, right? It breaks it down into increase or decrease for you, really to make things simple. Again, and this produces really a more digestible result, honestly, if you're saying are yards going to increase or decrease, given everything that I'm explaining by. And it's telling you things like the yard line, right? So if you're in between the fours, yeah, you're more likely to have a longer run, right? Doesn't that make sense? And if you're accelerating at a high speed, right, a high rate of acceleration, you're more likely to have a long run, right? And I found this one was interesting. Opposing territory. If you're in your own side of the 50-yard line, you're more likely to have a long run. Very interesting stuff. Whew. So let's flip back to the PowerPoint here. I want to leave you guys time for at least 10 minutes for questions. So what did we learn here, right? So this was, again, we didn't make a single prediction. We didn't predict we didn't make row by row predictions. We summarized our data with the key influencers visual, and we found out really what are the influential columns that really drive how long or short a run is going to be, right? So we found things like acceleration, speed, the defensive alignments, the weather. Isn't that, and that both is interesting and makes sense, right? How your offensive strategy, how big you are, right? This is what, if you really dig into this data and look at the key influencers visual, you'll also see things like really heavy runners. So people who are 250 pounds. Now, sure, you'll find a Derrick Henry every once in a while who plays for the Titans, but people who are really heavy, they're not going to break a lot of long runs, right? Whereas people who are under 190 pounds, they're more likely to go off for a long run. And then where you are on the field. So let's talk about how this might influence our dashboard design. And more specifically, I guess how we use it at IronEdge a lot of times. And I'll relate a past client example without giving specifics. We have, well, not a past client, a current client, right? So we're actually working on a estimation project for them. So really helping them go through their estimation data to arrive, to inform their estimators to make better, project estimates going forward, right? So one of the things that we did, and it was one of those things, we were creating very, very standard dashboards to answer, giving them ways to really go through and analyze and tear apart their data. One of the things we did is we started putting data into the key influencers visual, and it turned out that what they wanted to analyze really wasn't the most impactful, right? So what we found out was that the actual estimator really drove the success or lack of success of an estimate. So we used that information to start creating an estimator effectiveness dashboard for them. And so it's something that they can really use as a training tool with their employees, their estimators, to really help them make better decisions and make better estimates going forward. So for here, if I'm an NFL GM, I might start asking someone to break down dashboard by dashboard how players move, right? How fast are they? How do they accelerate? Defensive tendencies from my opponent, right? What do they what do they do? You know, what do they do at different parts of the field, different downs and distances, and use that with the knowledge I have on my team and how I run the ball to really start game planning. Very interesting stuff and very powerful stuff that we can start exploring all with the key influencers visual. And obviously, we'll open this up for questions now. But if you'd like what you heard today, please get in touch with me afterwards. I love talking about statistics. I love talking about BI. I love talking about Power BI. But if you want to keep in touch with us, all right, we'll have an upcoming webinar in the next week. If you're not already a member of the Houston Power BI group and you're located in Houston, if you're not located in Houston, find your local Power BI user group and join that community. But if you are in Houston, we host and sponsor the Power BI user group. Again, we'd encourage you, for obvious reasons, our April Power BI user group will be virtual. We'd encourage you guys to sign up for it through Meetup, through the actual Power BI user group site for Houston. Or if you'd like to stay in touch with us by following our blog, please do that as well. And with that, I'll open it up for questions. So if you guys have questions, feel free to either raise your hand or just more simply fire your question into the Q&A box. All right, so I guess I answered everyone's questions, or I put everyone to sleep, one of the two. Thank you, Greg. I appreciate it. And again, if you guys have questions about this, I love talking about BI and data science in general. And I would encourage you guys to, especially if you're data analysts, I would encourage you guys, if you're not already doing it, start using the key influencers visual. Use that to drive dashboard development at your company. I think it's a free tool. There's no code, and I think we've shown that it's really, really powerful. And hopefully you guys didn't hear my new coworkers now that we're quarantined. All right, guys. Well, if there's no questions, I will give you guys 5 minutes of your day back. And thank you so much for attending.